Hello. In this video, we're going to be looking into the chemical properties of alcohol. This video is part 3 in a series of videos that I've created on this functional group. In the first set of videos, we looked into the physical properties of alcohols, which was then followed by the second video on 3 of the main chemical properties of alcohol. The third video will only focus on a reaction whereby you get this observation, a color change from orange to green. And this is a reaction of oxidation. So in this particular video, we're only going to focus on oxidation of alcohols. We'll be looking into the different types of alcohols, 1 degree and 2 degree others, which undergo oxidation. Reagent that you're going to use is always potassium dichromate or the chromate ions, dichromate ions in presence of dilute sulfuric acid. The condition is you will warm it gently. You don't need to use a lot of reagent. When alcohols get oxidized, the primary alcohol will get oxidized to an aldehyde. And if you want the reaction to stop at the aldehydic stage, that means you'll have to remove it, because if you don't remove that, you would end up getting a carboxylic acid. So if you want the reaction to stop at the aldehyde stage, you will have to distill away the product. If you want the whole of the reaction to carry on, then you would have to use a reflux method. 2 degree alcohols will undergo oxidation to just give you a ketone, and ketones don't undergo any further oxidation. 3 degree alcohols will not undergo any oxidation, so they do not undergo oxidation at all. When you look at primary alcohol, so if I'm just going to show you a general formula of a primary alcohol here. Primary alcohols are those which are attached to, where the OH attached to the carbon, this carbon is attached to only 1 carbon atoms or none. So if this is a primary alcohol, that is RCH2OH, so this is your primary alcohol. When you oxidize it, so when you show oxidation, you write oxygen in this format and you put the reagent on top of the arrow. So that is you can put H plus, or you can write dilute H2SO4, or you can show it in this manner, the reagent. It's up to you. When you oxidize it, think about you've got the oxygen from here, remove the hydrogen from the OH, and then remove the hydrogen from the same carbon. So it's very important to identify where you're removing the hydrogens from, so that it's easy to figure out what's left out. So 1 hydrogen from there, and you got to think what is left out. So 1 hydrogen from there. So now I've got 1 hydrogen here on that particular carbon and 1 oxygen. Now we know oxygen needs a double bond, so that's the product. So if I have to write the equation in here, so I've got RCHO plus H2O. There are a variety of ways in showing this particular functional group. You can either show it in that format, or you can also see in some books they represent that functional group in this way. This is your aldehydic functional group. Aldehydic functional groups have got a carbonyl group. So C double bond O is your carbonyl group. When the carbonyl group is attached to at least 1 hydrogen, then it becomes an aldehydic functional group. So 1 degree alcohol will get oxidized to give you an aldehyde. The color change is from orange to green. As discussed before, if you want the aldehyde to be the only product, then you would put your 1 degree alcohol in here along with the oxidizing agent, which is your dichromate, acidified dichromate. Aldehyde will boil off, it it will distill and you will collect the aldehyde in here. Therefore, you are separating the aldehyde from the oxidizing agent and you prevent the aldehyde from getting further oxidized to carboxylic acid. So distillation, as you study at GCSEs, distillation is just a separation technique. Therefore, you've just separated an aldehyde from the oxidizing agent and thereby preventing it from further oxidation. So let's try out a chemical equation now. Let's try out oxidation of ethanol. Because it's got eth in the name, that means it has got 2 carbon atoms. So I can either write CH3, CH2, OH. That's ethanol. When you oxidize it, so you could pause the video and you can try out the reaction yourself. And if you've tried out the reaction, if you've paused the video, you can check the answer now. You would have had to identify which hydrogens you've removed with the oxygen as water and just write down the rest of the compound as it is. So we still have CH3. On this particular carbon, we have got 1 hydrogen and 1 oxygen. So we are left with 1 hydrogen gone, 1 hydrogen from here. So we still have CH3 in the first carbon, CH in the second, along with oxygen plus H2O. So 2 carbon, eth, all single bond, and all indicating alcohol. Here you would just call it eth, all 2 carbons, all single bond, and CHO functional group is aldehyde, and you just write al. So the name is ethanol. Ethanol. So if it was propanol, you would get propanol. Al indicates the aldehyde that is formed. If you want the product to be carboxylic acid, then you would set up a reflux apparatus. So what you would do is you would put your 1 degree alcohol here in the round bottom flask and you would put your oxidizing mixture, not a lot of it, but you would put that in this round bottom flask and you will continuously heat it. Now, organic compounds are generally, they boil off very quickly, they're volatile, so if you are heating organic reaction mixtures for a long period, you want to prevent the organic vapors to evaporate away and escape into the atmosphere. So what you really want is you want the organic vapor to come in contact with the cold condenser and then condense back. So reflux is just a process whereby you're continuously heating something for a long time because the rate of reaction is slow. So it's a slower rate. And you are bound to heat it for longer. But the problem is if you heat it for longer, the material would just evaporate away. So you plonk a condenser on the top. And what you're doing is effectively preventing the escape of the material. Now, never seal the top end. You would never seal the top end because if you seal it, the vapors will build up in here and it could cause the apparatus to explode. You would need to add, because you're heating it for a longer period, you would need to add anti-bumping granules in here. So when you add anti-bumping granules, it would prevent vigorous boiling. And it would start to create smaller bubbles rather than large bubbles. So it makes the heating more safer. In school labs, you would tend to use an electric heater when you are dealing with organic materials because it's much more safer. So we've looked into oxidation of alcohol in the previous one where we had just checked and formed an aldehyde, but if your oxidation is going to be under reflux, then you will not get an aldehyde, but now you would get acid. So I'll show you 2 steps. So this is where we were before. So we had CHO, which can be shown as CH3 C double bond OH. So that was your aldehyde. In the second step, so that's reaction 1. In the reaction 2, what you've got now is further oxidation. So all you need to do is just put the O here. So this is it. It's quite simple. So put the new oxygen here and that is it. There's no other thing, other molecule that's released. So now you've got CH3COOH and that is your carboxylic acid. And you get carboxylic acid only when you've got a reflux apparatus as a setup. So the observations that you see is mainly orange to green. The redox reaction that happens is you start off with chromate ions. They turn into chromium ions. Therefore, the color changes from orange to green. Right? And if you were to balance this redox reaction, so the oxidation state is +6 and then this is +3. So when you balance it out, to balance the electrons, you would put 6 electrons here. So it's an oxidizing agent. It itself undergoes reduction. You balance the oxygen, so 7 oxygen on the left-hand side. So you put 7 water molecules on the right. 7 times 2, 14H plus. So 14 hydrogen, you put 14H plus on the left-hand side. So that is the redox reaction that is behind this oxidation reaction. So overall, if you were asked to write down the reaction, you would have RCH2OH that in presence of K2Cr2O7 in presence of H2SO4 would give you RCOOH. Because it's an addition of 2 steps, reaction 1 and reaction 2, therefore you would also have water, and because you did 2 steps, you would put 2O there. So that is the overall reaction. Oxidation of secondary alcohol is, secondary alcohols are those that are bonded to 2 carbon atoms, and it's the same concept as in the prior example where you remove the O, H and H from the same carbon. So now you get RCr, you've got plus H2O, you're left with 1 oxygen, double bond O. In this case, you've got the carbonyl group attached to no hydrogen. Therefore, this is a ketonic functional group. So that's your ketone. So 2-degree alcohols always get oxidized to form a ketone. So if we look into propane 2-ol, propane means 3 carbon, 2 is here, second position. So now we've got that undergoing oxidation. So if I put Cr2O7 2 minus in presence of H plus, same as before, H from here, 1 H from oxygen from here. So I've got H2O removed, and what is left out is CH3C double bond O CH3. So that was propane 2-ol, and that becomes propanone, which is a ketone. 3-degree alcohol, if I look at 3-degree alcohol, if the hydrogen, there is no hydrogen left, therefore it will not undergo any oxidation. So in a nutshell, primary alcohol gets oxidized to 2-degree to ketone, 3-degree to will not undergo any oxidation. As you can see from, you can try this example yourself and you will see that it will not undergo any oxidation. So oxidation of butane 2-ol, will it undergo oxidation or not, is the question for you. So have a go. Is this primary, secondary, tertiary? Will it undergo oxidation?